Hey everyone, welcome back to Civil Score. Really glad you're here today. In our current affairs segment, we cover events that are not just news stories, but events with deep geographical and scientific concepts embedded in them. And today, we have one such event that genuinely made the world sit up and take notice. We are talking about the eruption of the Hayli Gubbi volcano in Ethiopia, an event that sent a volcanic ash plume all the way toward India. Now, why does this matter for UPSC? Because this single event connects concepts from physical geography, tectonics, atmospheric science, and environmental impacts, all in one place. So let us understand it properly, slide by slide. Let us start with where Hayli Gubbi is and why it erupted at all. Hayli Gubbi is located in the Afar Depression in Ethiopia, about 800 kilometers northeast of Addis Ababa, near the Eritrean border. It sits within the Danakil Depression, which is one of the hottest and most remote areas on the planet. More specifically, it is at the southern end of the Erta Ale volcanic range, and the Erta Ale range is already well known for its persistent lava lakes and shield volcanoes. Now, the geological driver here is very important. This region sits on a divergent plate boundary. The African plate is actively rifting, meaning the continental crust is being pulled apart from underneath. As the crust thins due to this rifting, magma from the mantle finds pathways to the surface, driving volcanic activity. This is why the Afar region is one of the most tectonically active zones in the world. For prelims, just remember, Hayli Gubbi is a shield volcano in Ethiopia's Afar region, sitting on a divergent plate boundary. That is the tectonic foundation of this entire story. Now, this is where a very interesting scientific twist comes in, and it is perfect UPSC material. Hayli Gubbi is classified as a shield volcano. Shield volcanoes are the largest volcanoes on Earth. They are built by repeated eruptions over vast periods of time. They contain almost exclusively basaltic lava, which is very fluid when erupted. Because of this fluidity, the lava flows easily over large distances rather than building steep cones. This is why shield volcanoes are characterized by broad, low-gradient profiles with gentle slopes. They look like a warrior's shield lying flat on the ground, hence the name. Now here is the paradox that the slide is pointing to. Shield volcanoes, because of their low viscosity basaltic magma, typically produce relatively gentle lava flows, not explosive eruptions. But the November 2025 Hayli Gubbi eruption was classified as Sub-Plinian, which is an eruption type known for extreme vertical column height and massive ash dispersal. That is highly unusual for a shield volcano. The ash plume reached 45,000 feet, which is flight level 450, penetrating all the way into the upper troposphere and even the stratosphere. The payload expelled included volcanic ash, sulfur dioxide, glass shards, and pulverized rock particles. So the paradox is this. A volcano that should produce gentle behavior instead produced one of the most explosive eruption styles. That contrast is what makes this event scientifically significant and exam relevant. Now let us trace the journey of the ash plume, because this is where the current affairs angle becomes very crisp and mappable. The ash started at point 1, the Hayli Gubbi epicenter in the Afar region of Ethiopia. From there it moved to point 2, its primary transit, drifting northeast across the Red Sea corridor. It then moved to point 3, the secondary transit, traveling overland across Yemen and Oman. At point 4, it crossed the Arabian Sea at high altitude. And at point 5, it arrived over western India, making this a genuinely transcontinental journey. What made this possible? High altitude upper tropospheric winds. Because the eruption injected material into the upper troposphere and stratosphere, the particles were picked up by these very powerful high-altitude wind systems and carried thousands of kilometers eastward. The payload carried across this distance included sulfur dioxide and glass shards suspended in the atmosphere. This is not the first time volcanic ash has crossed oceans. The 2010 Eyjafjallajökull eruption in Iceland disrupted European aviation for a similar reason. Same atmospheric mechanism, different geography. Before we come to the impact on India, let us take a moment to place Hayli Gubbi in its regional geological context. The East African Rift System is one of the most volcanically active regions on Earth. Several important volcanoes in this region are worth knowing for prelims. Mount Nyiragongo in DR Congo hosts one of the world's fastest lava flows. Mount Silali in Kenya is a massive extinct caldera volcano. In Ethiopia itself, there are several. Dabbahu is known for intense rift-related fissure eruptions. Mount Alaita is an integral shield structure of the Afar Rift System. Malale is a prominent stratovolcano structure. And Asavio is an active silicic volcanic field also within the Afar Rift. In Djibouti, there is Ardukoba, a rift volcano whose last recorded eruption was in 1978. All of these volcanoes exist because of the same geological story. The East African Rift, where plates are pulling apart and magma is finding its way up. For the exam, at minimum, know Hayli Gubbi and Nyiragongo by name and country. And now, the most practically relevant question. What did this eruption actually do to India? The slide breaks the impact into three categories. The first is air quality and AQI. The mechanism is that volcanic ash remained trapped at extreme high altitudes, above 15,000 feet, which means it had very limited vertical mixing downward toward ground level. The impact assessment is therefore reassuring. Major Indian cities like Delhi were highly unlikely to experience significant AQI deterioration. The pollutants stayed mostly aloft. The second category is health and climate effects through sulfur dioxide. When SO2 is injected into the atmosphere, it can theoretically contribute to acid rain formation. However, the assessment here is also relatively contained. By the time SO2 concentrations reached India after traveling thousands of kilometers, they were too diluted and limited to trigger severe acid rain events. The third category is atmospheric optics. Fine volcanic particles and pulverized glass shards suspended at high altitude can cause skies to appear visibly hazier or darker than normal. The expected effect is brief, localized disruption to solar radiation levels, and some reduction in high-altitude aviation visibility. It is also worth knowing what an ash cloud actually is. It forms when a volcano erupts and sends volcanic material into the atmosphere. It contains fine volcanic ash, sulfur dioxide, and tiny fragments of rock and glass. Health effects from direct exposure include respiratory problems, eye irritation, and skin discomfort. Though, at the altitudes this material was traveling over India, direct ground-level exposure was not a major concern in this case. And that brings us to the end of this fascinating topic. One volcanic eruption in Ethiopia, sitting on a divergent plate boundary, producing a paradoxically explosive Sub-Plinian eruption, sending an ash plume across the Red Sea, Yemen, Oman, the Arabian Sea, and into western India, all carried by upper tropospheric winds. This is what makes current affairs so rich for geography preparation. The concepts of tectonics, volcanic types, atmospheric circulation, and environmental impact all come together in one real-world event. Make sure you can place Hayli Gubbi on a map. Know it is a shield volcano in the Afar region on a divergent plate boundary, and remember the 5-step ash trajectory. That is your prelims package right there. All the best, everyone. See you in the next class. Take care.